Let's find an antiderivative of x over x squared minus 5 dx. We can rewrite this integral as x times x squared minus 5 to the power of negative 1 dx. Now we notice that we have an expression x squared minus 5 raised to the power of negative 1. So our choice of u would be that expression, which is x squared minus 5. Now here we take du, which is 2x dx. Pardon me. We can divide both sides by 1/2. So 1/2 du equals x dx, so that our original anti-integral x squared, x times x squared minus 5 to the power of negative 1 dx, which can be rewritten as x squared minus 5 to the power of negative 1 times x dx. So you notice that what I did is I just wrote the x next to the dx, so that I have, now this is x squared minus 5 is u, so u to the power of negative 1, and x dx is equal to 1/2, so times 1/2 du, which I'm rearranging as 1/2, the constant to the front, u to the negative 1 du. However, what's an antiderivative of u to the negative 1? We know it's natural log of absolute value of u, and then since we have the constant 1/2 as a coefficient, we have to multiply the antiderivative by 1/2 and also the constant of integration. And the very last step is to replace u by its expression, which is x squared minus 5, and then the constant. And this gives us the antiderivative we were looking for. Now let's go over another example. Let's say, for example, that we want to determine an antiderivative of e to the 4x over 7 plus e to the 4x dx. So we can rewrite this as e to the 4x times 7 plus e to the 4x, the whole thing, the whole denominator raised to the power of negative 1 dx. And once again here, our choice of u would be the denominator, or that expression raised to the power of negative 1, which is 7 plus e to the 4x. And right away we take the derivative. 7 plus e to the 4x, derivative of 7 is 0, and derivative of e to the 4x is 4 e to the 4x dx. And we can divide both sides by 4, so that we get 1/4 du is equal to e to the 4x dx. Remember, we keep the x's on one side and the u's on the other side. Now, the original antiderivative is e to the 4x 7 plus e to the 4x to the power of negative 1 dx, which I can rewrite as, I'm going to take this e to the 4x here and write it next to dx, and you know exactly why I'm doing that. So 7 plus e to the 4x, not 7x, to the power of negative 1 times e to the 4x times dx. And here I notice that this is u, so we get u to the power of -1 and e to the 4x dx. E to the 4x dx is equal to 1/4 du. So times is always times 1/4 du, and I can rearrange once again by putting the constant to the front, so 1/4 u to the -1 du, and an antiderivative of this is 1, so equals 1/4 natural log of absolute value of u plus c. Don't forget the absolute value. So this equals 1/4, and we can replace u by, this is the expression of u, 7 plus e to the 4x. So natural log of absolute value of 7 plus e to the 4x plus c. So this gives us the answer we were looking for. Now for practice, I'm gonna assign some problems. So find the antiderivative of e to the 3x over e to the 3x minus 1 dx. That's the first antiderivative to compute. And the second one is the antiderivative of 5x over x squared plus 9 dx. So this should not be difficult as long as you understood what we did before.